Now we're into kind of a new topic within the realm of power, running power. And this diagram I put together myself to help try and relay what is happening with running power. Now we transfer, if we think of a stride, we're trying to cover a distance every time we take a stride. And it's the goal of running. A to B. We want to get A to B, kind of left foot to right foot. Now, through that, we have to apply force, a propulsive force, and then we are traveling at a speed. And so that is our power, our running power. Now, it's slightly different in terms of the calculation because there's not that direct strain gauge. It's more of an algorithm that is taking the components that you put in, your height and your weight, and then the accelerometers within the foot pod or the chest mount or the wrist-based system, whatever you're using. Right at the base, we're taking the force that you're putting out on the ground to travel a distance. And that is, distance time is velocity. And once we know force because we know your mass, you have to input that, and then you have to accelerate. So you can accelerate through kind of space and time, I guess, and that's generally against gravity. Well, not generally, it always is against gravity because gravity is trying to slow you down.
Yeah, cool. I think it's pretty interesting to note the difference in how running power is calculated. Because normally what we're used to as cyclists, we're looking at it and there's these strain gauges built inside the crank, and we're looking at how much force is created almost directly because the strain gauge is measuring that force. And then when running power meters came out, we were like, no, you can't do that. Like, how could you measure power without actually measuring some sort of a force? But the really cool thing with physics, and this is why I just think it's energy equations and power are so cool, so there's lots of ways you can actually measure it. And if we know the weight of something, we know how fast something's accelerating, or we can calculate a force. Then what we can do is we can work back to get power. So the running power is still power, and it still works, and it just gets about it a little bit differently. I just think it's really cool.
That's right. So just recapping that, it's, again, the same equation. It's just the way in which we arrive at the numbers is slightly different, but it is still the rate at doing work. And that's why running power is so valuable in the new world of data, metrics, things like Training Peaks and analytics, and that now we're not having to rely on poor GPS data, heart rate, pace correlations when you're running uphill, or the differentiations in trail or underground terrain, because we have ground contact time, we have stride length, we have stride rate, we have all these variables that these devices are calculating to give us our power number, which we know how valuable that has been and changed the game in cycling, and now that's happening in running.